Recall from the discussion of the rock cycle that igneous rocks form when molten rock cools and crystallizes. Molten rock, magma, originates in the mantle and crust as a result of partial melting of solid rock. Because the magma body is less dense than the surrounding rocks, it works its way toward the surface, occasionally producing a volcanic eruption. Volcanic eruptions may produce pyroclastic debris, such as ash and cinders. Along with pyroclastic debris, volcanic eruptions can produce extensive lava flows. Igneous rocks that form when lava solidifies are classified as extrusive or volcanic igneous rocks. Most magma never reaches the surface. Rather, it crystallizes at depth to produce intrusive or plutonic igneous rocks. Although intrusive igneous rocks form at depth, uplifting and erosion often expose them at the surface. Intrusive igneous rocks are exposed in many places, including Yosemite National Park, Stone Mountain, Georgia, and within Grand Teton National Park. To summarize, igneous rocks form when lava cools quickly at the surface, or when magma crystallizes more slowly in a shallow pluton like this sill. Or at great depth over very long spans of time. Because magma is than the surrounding rocks, it works its way towards the surface, occasionally causing a volcanic eruption. Which of the following are not usually produced by volcanic eruptions? Igneous rocks, which form at the surface of the earth, are said to be igneous rocks, which form from magma that crystallizes beneath the surface, are called the rate of cooling greatly affects both the size and arrangement of the crystals, a property called texture. Rapid cooling produces smaller crystals, and slower cooling allows time for larger crystals to form. Igneous rocks that form at the surface or as small masses within the upper crust possess a fine-grained texture termed aphanitic. Notice that the grains in aphanitic rocks are too small for individual minerals to be distinguished with the unaided eye. Many fine-grained aphanitic rocks contain voids left by gas bubbles that escape as lava solidifies. These volcanic rocks usually form near the surface of lava flows and are said to exhibit a vesicular texture. When large masses of magma solidify at depth, they form igneous rocks that exhibit a coarse-grained texture described as phaneritic. In contrast to aphanitic rocks, the individual minerals in a phaneritic rock can be identified with the unaided eye. Rapid cooling of lavas may generate a glassy texture. Glass results when the ions are unordered. That is, they have not formed an orderly crystalline structure. Rocks with a glassy texture, like obsidian, also form when silica-rich lava is extruded as a viscous mass that solidifies as a glass. During some volcanic eruptions, silica-rich lava is ejected into the atmosphere, where it is chilled quickly. These events can generate a frothy mass of fine shards of intertwined glass called pumice. Match the textural terms by dragging the names in the center boxes to the appropriate rock samples. Click on the text which describes the environment in which this rock most likely formed. Click on the text which describes the environment in which this rock most likely formed. Click on the text which describes the environment in which this rock most likely formed. In addition to the igneous textures already considered, some igneous rocks have large crystals embedded in a matrix of smaller crystals. These rocks are said to have a porphyritic texture. The large crystals in such a rock are referred to as phenocrysts, with a matrix of smaller crystals called ground mass. Porphyritic rocks form when certain minerals begin to crystallize and grow quite large before others begin to form. Then the magma containing these large crystals migrates to a new environment where cooling takes place more rapidly. In this situation, the rock will have a porphyritic texture in which the ground mass is fine-grained, aphanitic. As shown in the sample above. In other situations, the magma may migrate to a smaller intrusive body where cooling occurs more rapidly, but still slowly enough to produce visible crystals. In this environment, the ground mass will be coarse-grained, phaneritic, as shown in the sample above. Based on what you have learned about crystal size and cooling rates, click on all the labels which describe the possible environments of formation for this rock. Click on all the labels which describe the possible environments of formation for this rock. Igneous rocks are classified based on their texture, and mineral composition. Using the various igneous textures and mineral composition categories, we can develop the table that is used to name the basic igneous rocks. For example, an aphanitic rock with a granitic composition is called rhyolite. Phaneritic rocks composed of quartz and potassium feldspar are called granite. A porphyritic rock with a fine-grained ground mass and andesitic composition is called andesite porphyry, and so forth. Click on the rock type with a phaneritic texture and andesitic composition. How about an ultramafic rock with a phaneritic texture? Click on the correct name. You can use this table as an aid to identifying igneous rocks. When minerals cannot be identified, the composition can be estimated based on the percentage of dark ferromagnesian minerals. Using the table, try to identify this sample. Remember, the key is to recognize its texture and mineral composition. Click the Igneous Rock Identification table for reference.